Okay, we're going to go ahead and solve this one out, and these require a little bit more finesse, if you will. And we also have to keep in mind that we're solving this time over an interval, which means is that we don't need all answers, we just need the answers that are in this particular interval, which is 0, including 0, all the way to 2 pi. And we're solving everything in radians. So the first thing that we want to do is that we want to take a look at this guy and realize that it's kind of like a quadratic imposter. And so for example, if I were to take all the sine x's, right, and I would let sine of x equal, let's just have it equal t, then I could rewrite this thing as 2t squared minus t minus 1. And from here, we could go ahead and solve this by factoring, theoretically, assuming that it factors out. So what we can do is this, is that, well, let's go ahead and factor this thing. We say, what two numbers multiply yeah, we can't do it quite like that. Let's just use our standard guess and check. Is that we'd have 2 in front there. We know t has to go here. So it looks like this is going to be a minus 1 and a plus 1. So just using, again, your standard reverse FOIL or factoring technique. We couldn't use the other way that I started it on because it doesn't have a leading coefficient of 1, and I didn't want to go through all that when looks like pretty much some armchair mathematics. So now, if I substitute sine back in, I can get 2 sine x plus 1, parentheses, let's see, sine x minus 1 equals 0. Okay, so now we're at the stage where we have the product of two things, and we can use the zero product property to finish this thing off. So now I'm going to go ahead and say, all right, the first one is going to be sine, or I'm sorry, 2 sine x plus 1 equals 0, and then we have sine x minus 1 equals 0. And what we do is that we get sine all by itself, and so we're going to have sine x equals a negative 1/2 after we subtract 1 and divide by 2, and sine x equals 1. So what we want to do is that we want to think about where these are going to occur one time around the unit circle, okay? So let's work on this right here. We know that we're taking the sine of some angle, and we're getting a negative 1/2 out. So we know if we take, all students take calculus, that we want to go ahead and find some reference angles that are going, when we take the sine of that angle, it's going to be negative. And so that's going to occur right here with a 30-degree reference angle, and right here with a 30-degree reference angle. So it looks like that the two angles that are going to work, the first one is going to be this guy, which should be 30 degrees more than one turnaround, or half a turnaround, which is going to be pi. So it looks like the first one would be 7 pi over 6, and the other one should go ahead and be all the way around here, which is going to be 11 pi. Made my 11 into a pi. 11 pi over 6. And that is just going to go ahead and be the first two answers, because we're looking at only one turn around the circle. We don't have to keep going. That is that as soon as we go this little bit more, we're beyond that 2 pi right here, and it's not necessary because we're only looking for these particular angles that are one positive turnaround. Next, we're looking for where sine is 1. And sine is 1 at, it appears, well, let's go ahead and think about that. I think the only place that we're going to be able to find it is right here, okay? Strictly because when we go like this, the sine of 90 degrees, or pi over 2, is going to be 1, and the 1 down here would give us a negative, and we don't want that. So the final solution is going to go ahead and be, that pi over 2. And so these are the three instances that the three angles that are going to, when you plug them into this original guy right here, that's going to give us 0. So that's basically what we found. Okay, so that's how you do that, and thank you for watching.